Welcome to EQS-electric, the channel for my Mercedes EQS 450 Plus. Today we're talking about consumption. Consumption at a constant speed of 90 kilometers per hour and 130 kilometers per hour, and average consumption over the whole time I own the car. And that's equal to 60 miles per hour and 80 miles per hour. Yeah, so, and I give you the data in watt hours per kilometer and watt hours per mile. Mercedes praises its EQS as the car with the best drag coefficient, the least air resistance, and the best range available. Well, probably everything's right with that, but not my car, because I do have a different outside trim, not the best one. And I have thicker wheels in diameter as well as in width. So the typical tire, the normal 19-inch rims, and the tires on that have 235 millimeters in thickness, and my have 265. This is an additional drag which the wheels provide during driving. Yeah, the design features I have, these AMG outside trim, if that's positive or negative, no idea. What I have the rear-wheel drive, single rear-wheel drive motor in it, the 450 Plus, and that gives, from the papers Mercedes provides, website features, Mercedes provides the best range in the whole cars from the 50 up to the AMG 53 something, no idea. The all-wheel drives show a significant less range than the rear-wheel drive models. Yeah, I had already 6 electric cars, and I've driven all of them on my test strip. There's an Autobahn very close to whiskey.com, where fine spirits meet, the internet portal for the whiskey connoisseur. We are running here in Seeshaupt at Lake Starnberg, in the south of Munich, Bavaria, southern Germany. And on that track I as well had a dozen other cars, from the e-Golf and the Hyundai, the Renault CEO, the Smart car, and a lot of different cars I had on that strip. And yeah, there is a problem in the moment. We have Roadworks there. So in former times I drove 4 exits and then turned around and took those 4 exits back, so that there is no influence of the wind if it's not too strong from the side, but then I'm not driving. And I drive a warm car, means that there's no heating of the battery. I switch the air condition off and I keep the air pressure inside the wheels to the standard value, but that I'm fixing at home at a normal temperature, so no hot tires. So the air pressure will increase during the cruise over the Autobahn, but I'm not caring about that. I'm adjusting the air pressure to the recommended value by the company. And today we have Roadworks there. All bridges have to be replaced because they are 50 years old, and the Autobahn was built for the Olympic Games in Munich 1972, and now all the bridges became old and have to be replaced. Yeah, so now the trip is shorter, some 25 kilometers, and 5 out of them is construction work, so the results are not as constant, as exact as I had them before. And for the 90 kilometers per hour, 60 miles per hour tests, those are quite equal, because the speed in that is 80 kilometers per hour, means 50 miles per hour. So that's quite constant, or not far away from the target I'm driving, and therefore consumption is comparable. But for the 130 kilometers per hour test, which is, well, suggested speed on German Autobahns, they are unlimited. Please have a look at my video about top speed and top consumption of that car. Well, I drove over 100 kilometers at maximum speed, which is 211 kilometers per hour. So it sucked 48 point something kilowatt hours per 100 kilometers. yeah, so this was quite a high consumption of that car, but not as high as I thought. Yeah, so there are some consumption values already available here on the channel. I give you the links to the videos below. And today, or in the last weeks, I took my tests, and not to let those figures stand for itself, we also have a Model Y, a Tesla Model Y from September 2021, long range, all-wheel drive, and with that I compare the values in the later curves and table. Here you find the diagram where I put 3 points in: the 50 miles per hour, the 80 miles per hour, and the daily average, and I switch over between the kilometer per hour and the miles per hour, and as well the watt hours per mile and the watt hours per kilometer. And here you see the energy consumption for the EQS 450 Plus with these AMG 21-inch rims and the width of 265 millimeters. And you see that compared to the Model Y with the standard 19-inch rims, and it's exactly the same. Well, quite not very exact, but quite the same. This was, well, astonishing to me. I thought the Mercedes would have had a much higher consumption than the Tesla has, because it has more weight. It's really a big car, and so I thought it would be more. Now switch over to the table, and here you have several columns. There is the EQS 450 Plus AMG 21-inch column is the first. Model Y 19-inch column is the second. There you get those figures, and those are so close to each other. This is inside the measuring tolerances. So I'm not that exact, and sometimes you have to reduce the speed for 100 meter from 130 down to 120 because someone is passing slower than you are. So there are some small differences in it, and there might be a light side wind during one test and not in the other. So there have to be differences, and that they are matching that exactly is something of a, yeah, it's arbitrary. Then you see the delta. It's 0.7%, 1.1%, and minus 1.4%, so nothing weird here. And then you see the range of the EQS. The top 3 rows is in kilometers, and the down 3 rows is in miles. And here you see this car shines to the specification, where you give you some 770 kilometers of range. And with this data at a constant 90 kilometers per hour, you reach 799, say 800 kilometers of range. With the same consumption, the Model Y does not reach that distance because the battery is smaller. The net capacity of the Mercedes is 107.8, and the net capacity of my Tesla, which has the LG battery, has 70 kilowatt hours net capacity. And there you reach those 522, and that's quite that what specification gives for the Tesla. So everything is just in the typical data you find somewhere at the companies. This is what the data shows, and as I said, I'm very much happy that the Mercedes is that good. And hopefully I will get the 19-inch rims with standard tires, summer tires. I will buy them used so that I have a first test with summer tires and the 19-inch rims, and then I switch over to winter tires and have another test later that year. Yeah, winter is coming earlier and earlier here at the slope of the Alps, so might be that I'm switched to winter tires in October. There is a difference in the average consumption of the car, because the average for the Model Y was calculated out of 10 months now. 6 of them had been winter, And in that winter, I drove to the Arctic or north of the Arctic Circle in Sweden in February with temperatures down to minus 20 degrees centigrade, minus 4 degrees Fahrenheit. So it was real cold up there, and we had an extra consumption there. So this data in average will fall, and today I'm just seeing that the average of that car, of the Model Y, is falling down to 209, I see in the moment. And when we're going to winter, the consumption of the Mercedes probably will go up a little bit because the car has no heat pump for the heating of the inside of the car. Electric cars still have a big potential of using less energy with upcoming models, because I once calculated the theoretical consumption of the car due to rolling resistance of the tires and the air resistance due to the drag. And if you add that up, typically with the best car, that was a Tesla Model S, then you reach 55% of the total consumption. So there was 45% unknown consumption, which might come from computers, come from resistance in the gears, the fixed gears, due to efficiency of the motors, the inverters with their computers in it, and heating and everything. So, or ventilation, I always switch the heat and the air condition off. So this is what really is in potential in these EVs. On the other hand, we see those fossil cars, they have constant consumptions since more than a decade, say 15 years, the consumption isn't lowering. So there is a lot of potential in these EVs, but not in the fossil cars. Yeah, I will see what will happen in the winter if I'm missing the heat pump, or if it's quite normal, like the early Model S from Tesla, they didn't have a heat pump either, that this will not harm a lot because the car is very good insulated and the dissipating heat from the motor might be sufficient to heat the inside of the car down to minus 5 degrees centigrade something. Yeah, that's it for today. Thank you for watching. Stay tuned. There's more to come.